Okay, let's do this. Today it's time for Advent of Code Day 9. Let me pop out the chat and put this in. I need to switch accounts. I have a YouTube Premium with the family, and I have this one that's linked to my business account that I can't connect Premium to. So yeah, I need to make sure that I use the proper account, otherwise I can't post links. So let me reload this. Yes. And now I can pin the link, pin it in chat. Okay. So yeah, let's start to read Advent of Code Day 9. Day 9, rope bridge. This rope bridge cracks as you walk along it. You aren't sure how old it is or whether it can even support your weight. It seems to support the elves just fine though. The bridge spans a gorge which was carved out by the massive river far below you. You step carefully as you do. The ropes stretch and twist. You decide to distract yourself by modeling rope physics. Maybe you can even figure out where not to step. Consider a rope with a knot at each end. These knots mark the head and the tail of the rope. If the head moves far away from the tail is pulled towards the head. Due to nebulous reasoning involving plank lengths, you should be able to model the position of the knots in a two-dimensional grid. Then, by following a hypothetical series of motions, your puzzle input for the head, you can determine how the tail will move. Due to the aforementioned plank lengths, the rope must be quite short. In fact, the head and tail must always be touching. Diagonally adjacent and even overlapping both count as touching. Okay. So H is head, T is tail, okay. If the head is ever 2 steps directly up, down, left or right from the tail must also move 1 step in that direction, so it remains close enough. Okay. Okay, so yeah, it just moves along with it in pairs. Sure. But they draw an intermediate step, so there's probably something there. Let's see. Otherwise, if the head and tail aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. Okay. So it will... Okay, so if that one moves up, it moves diagonally so that it's then adjacent. So once you're diagonally, it can only, after moving, it would always be right adjacent. Let's see. You just need to work out where the tail goes as the head follows a series of motions. Let's see. So if it goes up, if it moves, let me see. If it moves to the, no, in this case it moved, where did it go? It moved 1 up. So if it goes up, then it will be under it, so like in the opposite direction. If it goes to the right, it will be left of it. So I think that is probably important to know. So it will always be at the inverse of where you moved. So you just need to work out where the tail goes as the head follows a series of motions. Assume the head and the tail both start at the same position for overlapping. For example, right 4, up 4, left 3, down 1, right 4. I wonder what happens when it moves in on itself. That isn't explained. Will it swap positions or will it move along with it? Let's see. H covers T. Okay, it can cover it and then it will not move. Okay. Series of motions, then up first step, blah blah blah. You need to update the position of the tail if the step means the head is no longer adjacent to the tail. Visually, these motions occur as follows. Yeah, okay, so basically it says only when they're not in the same position or directly adjacent in either of the positions, then you need to move. Okay. What is S here? The lowercase s. That's weird. S marks the starting position of a reference point. Okay. So yeah, and here you can see it moves diagonally. or well, it moves up and then it's diagonally, so it's still like within one position, basically, or it's still somewhat adjacent. But then when it moves up, it connects to the other side of the position where you moved. So that's basically the flow, what I can see here. Okay, this is doable. Let's see. After simulating the rope, you can count up all the positions the tail visited at least once. Ah, okay, so that's basically becomes a hash set that after the moves is done, you keep track of the position. In this diagram, S again marks the starting position, which the tail also visited, and pound marks the other positions the tail visited. Okay, so there are 30 positions the tail visited once. Simulate your complete hypothetical series of motions. How many positions does the tail of the rope visit at least one? Okay, this seems very doable. Hey Sunco Software, good morning and nice to see you. Okay, maybe I'm overly confident, but it feels like this one is easier than yesterday. Less tricky, but we'll see. Usually when I say stuff like that, it bites me in the ass pretty fast, so... Okay. Program, let's make sure we run day 9. We don't need to do this. Let's see. Okay. So basically it's a combination of a letter and a number, right? Separated by space. It's even just one check. Okay. That's easy. So yeah, let's do that. For instructions is input that to lines, select x dot split by space, because that is our mapping, and then we do let's build a dictionary of moves, char comma int x int y. Move map is new this. So now we do up. I don't have it mapped. Okay, up basically becomes 0 minus 1. Let's see. Up, right, down, left. Did I have? Oh, I have a period instead of a comma. Okay, so up, down, down is increasing 1. In this case, to the right adds 1, to the left removes 1. Okay, so these are the mappings. Bum, 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 bum. So then we do move map x, because that is a char here. We expect only 1, so we can do it like that. And the second one will be no, actually it's a byte, but parse x. So now this becomes a list of and the first is int x, int y, and this is called the move byte amount. So yes, this is our instructions mapped, and I need to increase my font size, as I always do, so that it's easier to read on stream. Sorry for that. Hey Luc, goedemorgen. Goedemorgen. Luc is here in the office with me, so he can tell me to my face, good morning. So let's see, we map these. So now you can see a bit what I've done. Let me see here. So now we, let me see, do we know the start position actually? Is there an no, it's arbitrary, right? So we don't know. That's fine. So let's say we start at we start at 0, 0. We also have a hash set of the same type that we track the visited in. Tail visited is this. Okay. So now we do for each var instruction in instructions, and we also need to do head position and tail position is okay, it's the same. We do bool is adjacent and this is basically math.absolute head.x minus tail.x smaller or equal to than 1. So it's either 0 or 1 and then it's good. Math.absolute head.y minus tail.y smaller equal 1. Let me move this into view. So basically this means it's still adjacent. Actually I can, let me see. I also need to know when the offset is more than 1. No, when it's basically, let me see. If it's not adjacent, it moves to one position to the opposite of where I moved. So I think I can cheat that a bit. So let me see. We do a head position is head position dot move instruction dot. Let me write this without a typo. Instruction dot move. I'll do for int I is 0, I smaller instruction dot amount. Okay, and now we do if not is adjacent head position tail position. Basically we need to do tail position is head position dot move, and then we do instruction dot move times minus 1. But we need to do both of them. So move dot x instruction dot move y times minus 1. And basically this should be the last. Yeah. So this is the instruction. Basically, Oh no, but because I need to do everyone because I need to track it. I was like, I can just cheat and just take the end position and then move it to where it needs to be, but that's not true. I need to do it properly. I need to do this every time. So we check if it's not adjacent. Then we need to move it like this. I actually had the logic. Why do I delete it? If it's not adjacent, then we move, and then we do track tail. Okay, so we have here action of the same type. Track tail. T-pos. And I could just get it from there, but I think this is just a bit nicer. If not tail visited contains T-pos tail visited dot add T-pos. Okay, this is basically a one-liner. There it has an if statement. Let's just keep it like this. Track tail, and it probably needs to do that for the first position as well, right? Let me see. So in the end map, it has the starting position visited, so that excludes the starting position. Okay. So what we do is just we do the same here. I will just remove it at the end. Let's see. If tail visited contains start position, tail visited remove start position. It's all that right line. Tail visited positions. Okay. Tail visited count. Let's test it on the input first, because I want to make sure that it's correct. Because I took some liberties, I want to make sure that I didn't mess that up. Let's see. So this is, and then we do that like this. Okay, let's run day 9. And let's see the actual output. Code runtime, it didn't write anything because that is interesting. Did I run day 9? Yes. Okay. What happened? Test 12 positions. Let me see. Or maybe I scrolled. 13 positions. 2, 4, 6, 8, 9, 10, 11, 12, and okay, the S as well. This is also tail visited and marks over. Okay. So we include the start position. My bad. So this is bullshit. And we start out actually by saying that the start position, tail position is in there. Okay. Tail visited 13 positions. Okay. So I guess the code was pretty okay. Let's run this. 6522. Okay. Let's submit that. Woohoo! Yeah, that felt fairly easy. Let's see if part 2 is any harder. The rope snaps. Suddenly the river is getting a lot closer than you remember. The bridge is still there, but some of the rope that broke are now whipping towards you as you fall through the air. the ropes are moving too quickly to grab. You only have a few seconds to choose how you arch your body to avoid being hit. Fortunately, your simulation can be extended to support longer ropes. Rather than 2 knots, you now must simulate a rope consisting of 10 knots. 1 knot is still the head of the rope and moves according to the series of motion. Each knot further down the rope follows the knot in front of it using the same rules as before. Okay. Using the same series of motions as the above example, but with the knots marked H1 to 9. Okay. The motion now follows. Okay. Now I need a sip of my coffee. But that's okay. Because basically it needs to follow each parent. So what we need to do is actually keep track and then move each one and move them down the line. So yeah, this is very doable. Unless there's a different in the logic. Let's see. No, I don't think so. Let's see. Now you need to keep track of the positions the new tail 9 visits. Okay, so just the last one. In this example, the tail never moves, so it only ever visits one position. However, be careful, more types of motion are possible than before, so you might want to visually compare the simulated rope to the one above. Okay. I think I'm still okay. But yeah, let's see. Let's first implement this. So this now needs to be something that has more knots. So basically you have this, and now you have a list of knots. Number of tail pieces is 9. For int I is 0, I smaller than number of tail pieces, increment I, and then we say tail knots, add, start, no. Okay. Everything starts at the start, so that is okay. So basically now we need to go for int is 1, I smaller than number of tail pieces, increment I, and I'll tell you why. Because first we need to compare the head to the first tail. And we don't need to track this, we need to track the last tail position. Tail knots, number of tail -1. Okay. Okay, this becomes J. This is, by the way, stupid. So you should never nest your for loops with I's, because you often end up modifying the outer loop number and get into infinite loops. And I see somebody waving his head that he had that same issue this morning. So yeah, always be very, very careful when you nest for loops that you enumerate yourself. That's also why most people prefer stuff like .range and iterate on that with a for each, just so that you can't make mistakes like this. So beware if you do something like this. And also what happens is that, oh, you notice I already use I, so I'll change J here, and then you forget to update the last. a variable. So yeah, just be very careful if you do stuff like this. So yeah, now we do this logic, but we compare them to the -1. So let me just do some variables in here. Previous not, current not. So now we do and I can actually do previous not is this one, and then shift that one over every time. So we can do previous, oh no, actually this will be current not actually. My bad. So now you can see previous not is current not, and then current not becomes this one. No, J. As I said, this is tricky and the chances of you messing up are not null. So yes, now we need to update this, and that's a good one. Let me see. Now I need to remember, because at the start we can just take the move that the parent made. So now what we probably need to do is just look at where it is relative to its parent. No. This is a tricky one. Let me go back to the example. Haha, they just make a straight edge here. I just wonder how this one, if this one goes down, the last move that this made was down, and then it should snap to that. But how does this one then move? Let me see. I need to check the examples here again, just to see that specific case. For when it goes to the left here. Okay. When it goes to the left, that one snaps to the left. Let's see, right? That one goes to the left, this one snaps up to there. The chain follows itself downwards to where it was before. So relative to its old position, it keeps that position. So is that the trick? Let me see. H here. It goes down and it goes over. It's hard to tell, really. Let's see. That one goes down to there, and it goes in, then in on itself again. It's covering the H. Wait, what? So where was the 3? It was also at that spot. Okay, so this is an interesting one. So here you can see and I think it still follows like the parent move there, right? So this one moved left, so this one snaps behind as if it also moved left. So I still reference the original move. Okay, let's see if this works. So I think it's still the instruction that you actually do. Let me see if that works. Head position put move? No. So this would be the... Let me see, I need to move... Okay, I'm inspecting this one right now and I compare it to my previous one. So the previous one is the parent that I look to. Does that even matter? No, because I need to move the current one. So the current one is the current one and we move that by the instruction and then we track it. Okay. Do I want to test this input here just in case? I think that might be smart. So what was the end result? 36. Okay, let's see. Let's see if I coded this correctly. Okay, 80. That's not correct. Damn it. Okay. Yeah, let's print a map then, I guess. Void print map int x int y head list tails. Okay. Int min x max x min a max a. Let's call it T so that it doesn't get too confusing. So we have, because I need to set up the matrix to draw, right? Max and then we do a min and another max. This one needs to become y. So we do for int min y. Int y is min y smaller or equal to max y plus y. You could use input min, input max, input abs. Nope. Let's see. Let's see. Same for x. For int x is min x smaller or equal max x increment x. Let me see. I'm just wondering if I even need to do this, but we can do. No, I don't need to do this. Actually, I just needed to have both the min values and just subtract the ranges there, just to make sure that I print in a normal. No, I'm still using 2019. So let's see, console.write h else if bool match is false. Let me see. For int I is tails dot count -1. Let's see. Let's cache that. Int tail count tails count, because it will check this, because it can change every time. I larger equal to 0 I. So this will be the index, and then because we need to write the highest value, I think, right? Let me see. When it moved over each other, do you see the highest or the lowest value? I think the highest, right? Yeah. Oh no, the lowest value. Okay. Okay. So we don't need to do it this way. We can just go I is 0, I smaller tail count, increment I. If let's do this as well. Tail is tails I. If tail.x is x and tail.y is y, match is true, break. If not match, okay. And then we do I plus 1. Okay, so this should how many moves were there in this instruction? I'll just print it out before and then now after each instruction. Just here, print map head tails. Right. Head position, okay. And then tail knots, okay, also good. Let's add another console write line after, so that it spaces it out. Wait, what? Huh. Okay, that is weird. How is this even possible? Nice. Okay, let's step through this. Oh, Jesus. Let's see. Maybe I'm overwriting stuff. I thought it would be a value type underneath it. Let's just... let's see. Just to make sure. Shouldn't matter there, right? Let me just step through it for now. So now previous node is that, current node is this, okay. So this should be fine. And these are all still just 0, right? Okay, makes sense. So now it's no longer adjacent. So now we do head position dot move. Yeah, we do one opposite. Ah, okay. Yes. So now that one moves, okay, and that this will not cause any other one to move. So let's just set breakpoints here. Okay, so now we have the tail knots, and which one needs to move now? I think it's still the first one, right? Yes. So now the first one will be at 2, which will cause this one to also move. Oh wait, let's see. Ah, and this is where it goes wrong, because current knot is not updated. Its reference value is its value. Okay, so I need to make sure that I don't do this then, or I can just do it like this to make sure that it's double updated. Yeah, because this is the only time that it needs to write. Okay, let me just disable this for now. Run it again. Let's see what it spits out now. Still 80 positions. It still does stupid stuff. Okay, nice. So let's see here. Okay, so then we move that. So let's see. Now it has moved a few times. Wait, okay, so this is interesting because this one isn't correct. It actually needs to be yes, because yeah, I was stupid, because it needs to be the previous knot and then moved in the opposite side of the direction, right? No. Ah. Let me think. Yes, it did need to do this. So why is it wrong? Let me see. Because we have the head position is now at 4. This one follows at 3. So how come this one is now at -1? Let me just add this to a watch. Dun, dun, dun. Add watch and see what it wants to do, because this is weird. And let's also add this one to a watch just to make sure that I'm not seeing things. So these ones are still okay. So let's just debug this part. Okay. And let's also add previous knot here just so that we know what it's. So, okay. So this is weird. So we do need to sample the previous knot here and then make that opposite move. Yeah, because it's the same here. I do the head minus, yeah, okay. So I need to have my reference correct. So this one, yes, okay. So this one now makes sense. Then it goes back onto each other, then it's fine. Okay, let's see if I run this. Where do we end up? 79 positions. It's still stupid. Okay. So here you see that a gap starts to exist, and I wonder why. So let's do if not is adjacent. And I need to update this actually. So that might be it. Yeah, I think this could be the issue. Just reference tracking 84 positions. Well, at least it followed now. I just don't know at which step that is. Let's see. Because it did something similar to what you see here. I just don't know where this one is, and then it also reverted itself. No. So there's still some issue with the movement there, and what I do currently is I take the actual movement as the way to snap, but that's not correct. I had an example where I saw how it moved. Let me see. There was something around here, right? This was all still fine. Then it moved in on each other. Where did I see what I thought that I needed? Let me see. H2. Which one? Going down. To the right. One more to the right. But the 2 is still underneath it, so that doesn't tell me anything. It moves in on itself. Yeah, the thing is, it follows the... In here, what it does is that it follows the main direction of this one inverted to its next chain. So I wonder why that doesn't work for me. Let's debug this some more. Let's see. So the tail knots, are they all adjacent now? Yes. Okay. So this should still be fine, right? Yes. Let's see, tail knots. So now they need to shift over. Let's see. This is still correct, in my opinion. So this one needs to shift over, that will become 2, yeah, okay. So now still these tail knots, they are all connected, so that is good. Okay, so now is the next move. And what kind of move is it? It moves up, okay? So that should mean the first one shouldn't need to be moved, which means none of them need to be moved. but we do this 8 times. So the second time we do get an offset. Right? Okay, so let's see. We have the current knot here. This one is 3. Let's see. Wait. So this went from 4, 0 to 5 minus 1. Should probably print this out. Because it wants to go from 5 minus 1 to 5, 0, so that it's adjacent, but maybe it needs to be, because this was 3. Should probably. So this is our map right now. So this one, I wonder what it needs to do. If it needs to go like to this point or to this point. So that is the interesting thing that I need to figure out here. Let me go back to the movement, because I think I'm missing something here. Because I think I was too clever with part 1 and now I'm having issues with this. Let's see. One step in that direction so that it remains close enough. Okay. If the head and tail aren't touching, But the thing is, if it moved, because everything, if I move it here, it always moves like this. Basically, I need to track the move that this made and then repeat it or something? No. I should actually do the... Okay, I think I have an idea. Let me see. Yeah, I've played Snake. Let me see. I just need to do this in my head now. Move is actually new pause.x minus dit.x. New pause.y minus curved. So this is basically the move that it makes, and if anything needs to change, it needs to follow that same direction, probably. Still not 100% convinced, but let's see if this does more than similar, if this is what I need to do. Why doesn't it like this? Is it not assigned? Okay. Let me just run this because... Nope. Okay. What am I not getting here? My big issue is that I don't know how the snake needs to move when it becomes disconnected. Because if it's like a diagonal move, like let's say you have this one here and it moves here. Does it now get attached here or here? Or does it go here? It never goes here, I think, because that's not how the old code worked. It would always connect here or here based on where this one had moved before. So if, let's say you have this one and this is the head, right? And the head moves here and then the head moves here. The first time it doesn't do anything. The second time you get, and then there will be a gap here and then it will be here. And what it does is that it will always, because it moved to the right, it will always connect to this side and not to this side. Basically I could check which one of the axes is bigger and then... Yeah, when you move snake, everything follows the same path. So. But snake doesn't work like this, because in snake it just traces a path and everything follows the head where it's been. That's not the same as this. Because here you can have one part move while the other part doesn't. So, and yeah, I played it on a Nokia, so maybe you're referring to a newer version that moves differently. But in the old Snake, there are no new paths. Everything follows the head exactly. So there's no rope dynamics like this. But I think what I need to do is figure out if this side, is, the difference in this angle is larger than this angle, it should move to this side. Probably. That's what I'm thinking. So if the... Wait. That still doesn't tell me how it should move though. Just trying to visualize it in my head, because the issue is when it moves back and how that follows. You know what? I have Luke here. Luke, maybe you can explain it to me.
Yes. A simple hint, the tail doesn't have to move in the same direction as the head.
Yeah, but I don't know where it should move. That's the whole issue. I can't figure out how...
Every path in the tail follows it, the same logic for the previous path in the tail. So the one follows the head and two follows one.
Yeah, I tried that just now.
No, because you will still have the movement based on the original movement.
No, I had it based on the previous one. I tracked the move that the previous one did. So let me redo the code that I had, right? Hey, look.
Hi.
I did. So when the head moves,
Yeah.
it checks does the next connected one. That's the only thing that can trigger a waterfall down to these. So I track that move, and then I use that move to move the current one.
Yeah, but now you
I need
this
to do
one is only for the first.
Yes.
Yeah, but the second one can be different. The move of the second node can be different of the first.
Yeah, but what is it based on?
The position of the first. It is not based on the movement.
I don't get it.
Yeah. It follows a path, and it can go. When you go back to the instruction,
Sure.
you can down. And yeah, when you see the H, the head moves and moves and moves, and that the 2 doesn't move.
Yeah, because it's still it's not it's still linked.
And until it's there, this one moves down, but the rest doesn't move. And
this one goes to the right, so what it does, it hooks up next to it. Yeah, I do that. That's not the issue. It's when this then goes out of scope. When this one would start to move down, how does this one?
They always follow.
Yeah, the original move.
No, they follow the movement of the previous.
Yeah, that's what I tried here. I kept track. This is the move that this one made.
Yeah, but
so if you do that move, that means that the other one does the same move.
No.
Why not? Then how do you determine what move it needs to do?
Because every move, you should place that move in this part.
Yeah, I do that here.
No, you determine the move of the previous. This is the move of the head.
This is the
move of the.
Yeah, this is the move of the first tail piece.
Yeah, but you should. Yeah, and that's the move for the second tail piece.
Yeah, that's what I do here.
Yeah, but the third tail piece is going to need the move of the second.
Okay, because that can also be a new diff here.
Yeah, you can just track.
Yeah.
I just determine the move.
Yeah, the same way here. Yeah. Damn it. So for new boss is this one. Let's see, and then move is do the same here. That's still the same logic. Okay. It doesn't like this. Let me not print out. Where do I have all the print maps? Okay, so something weird is happening here. It's like I got an infinite loop somewhere now. No. Now it visited 94 positions. That's even worse. Jesus Christ. It should be this one, right? New pass, previous moves, that. that's completely wrong for what I needed. It's actually the inverted of what I needed now. What? Oh yeah, it needs to do... no. Let's see, what happens if you move? That's also not correct. Is it? Let me see. New pause. The move tracking had a bug there. Jesus Christ. Okay. That's why you subtract X from Y. That doesn't work. Okay, does it spit out something sane now that I catch that bug? 88, no, still not. It would be great to just visualize it every step still. I should probably do that. Should probably just, for now, just print the map every iteration. Just so that I can visually see what it does. Right? Let's do a few steps. So yeah, over here it's already messing up. So this logic isn't working for me. See, because I have tails. Let's see. Because this is already wrong here, but I already moved one, right? So yeah, this is just not correct. Your prep map will prep while you have gaps if it is in the tail move. Oh yeah, that is also true. I'm just getting a bit frustrated with this not working. Let me just run this. Okay, so here it has a gap after it's done, so that is just not correct. Because it's at the end of the instruction move, so this just, it's not correct. this is also because it needs to be because I still do the wrong thing here, so that makes sense. No, it still ends up with gaps there. Let's see. Tail knots. Let's just dump them in the watch so that I can see them more easily. Oh yeah, here it already updated. So the first one we know it moves correctly, right? That one will always follow suit. That's not the issue. It's just, let me see. And also, I probably shouldn't need the absolute distance that it moved. Let's see. The thing is, I need it like normalized, because sometimes it can jump 2 places, but we don't need that as a move information. We just need I'm just thinking now, because I need to move the current knot based on the move there, because the move is based on the previous one. So is this the thing that I need to do? Let me just stop it again. Print all the moves you make. Yeah, sure. Console.writeLine. J, this one. Let's run this a few times and see what it says. Pom, pom, pom. So yeah, this is just wrong. So let's see how it determines that move there. Yeah, I have the print map. Let's see, because it's the not 3. Okay, so I2. Okay. Or J2 in this case. Okay, so now here, the move that it determined is wrong. Oh, so I actually need to do it again. Let me see. Start here. So now it says the new pause is 2, 0, but the current is 1, 0. And I have the same error here as in the other place. I fixed it before, but I subtract x from y. It's like stupid stuff like that you don't see for a long time, that just messes you up majorly. Okay, let's see. So now it works. Let me see. 22 positions. I'm not sure if that's correct. Because it needs to be 36. Yeah. Let me see. And it's still off here. Looking that, yeah, but still not correct, because there's a gap here. Let's see if I can match up some of the moves here. I should do the small example first, by the way, just so that I can track this first initial one. Jesus Christ, this was annoying. I had so much fun with the first part, but jeez. Okay, so let's run this. What's happening? Okay, let's see. Because this is one that we should be able to track and see what goes wrong, right? Oh, and I move in the opposite direction as what they have, so that's also nice. But still, this one is wrong, because it only prints after the set of instructions, and it still leaves gaps. So here it does the same, it goes from 2 to -1. And let me just print it out after each instruction there. Basically what I did here. Is that true? Because that would flip it every time. No, that's totally not it. So I'm wondering if I do this one wrong. No, because this is the one that needed to be done. So that is good. X, X, Y, Y. Let's see. Oh, you have an extra print map in the head part. Yeah, I can do that here. Let's see. Ah, I don't have a print map here. Yeah, that's correct. Actually, let's. I had the print map in the wrong place as well. What was it erroring out there on? Should be this one. Let's see, error list. Name J doesn't exist in current context. Not. This is just not one. Okay, so this should be a full map of what it does. Let's see. 1H, 2, 3, 4. Then it goes one up. Then it goes up another. So it follows this one correctly. So that is correct. Let's see what happens here. That's weird, because when it goes up one here, they just, this one didn't need to go up one, right? Let's see. Oh no, this one snaps to, but this is what I meant before, like it follows the move that the parent made, right? It does the opposite of the parent here. Let me see if that is true, because that won't mean that this one goes to the right and then that one follows that. Ah, okay, let's see. Let me see. This one does, it takes the head, so the new position of that one and then adds the inverted move of that. So it would be new position is previous knot and then invert that move. I think. Tail visited one position. Okay. Let's see if it did what I expected to do there. Nope. But then still apply it to, wait. But isn't that what I just said? Like if you look here, basically the one moves up one, which basically means that the two that's disconnected just mimics what this one does, but in inverse. Based from this position, it becomes this negative to what it did. Or is it just the previous position of that one? Am I making this too hard? And do I just need to set its previous position there? No. Actually, that could be it. That's not it, right? No, because this one also moves up one. Yeah, this entire row shifts, and they were never here, so that's bullshit. So I wonder, when this one goes up, why this one needs to go below this one, because it goes up and to the right one. And how do I know that based on this? Because previously what I always did, I was just look at the thing that moved and take that in the opposite direction, right? When this one goes up, it gets it gets put below it. Two. I'll do a diagonal upright, yeah. But the thing is, this one move, it doesn't do that. So the previous one just went up one. So why does this one go up and to the right? Because if you follow this, the H goes up. Let's see, goes to the left. Like from here, the H moved up one, so the 1 moved up 1, right? Then the H goes up again, the 1 goes up 1, but this one goes to the right and up 1, right? So what I always figured I do is I take the previous one and do the inverse of what happened there. And that would give me this one. That logic pans out. But then this one makes a similar move. Which is let's see, this one goes up 1. So if I so that's just the weird thing for me. The head moves, then this one moves, and the move that this one does is just a simple 1 up, right? This one then does a diagonal move, which is weird, because it goes 1 to the right and 1 up, while the previously only went 1 up. Because logic dictates that if this one goes up, it could also have just moved the 2 to there, instead of going here and pulling everything up. Right? So, let me see. If you take that example to the left there, it has 5, 4, 3, 2, 1, H. So when this one goes up, it could also just shift this one here and then leave this one as is. Why did it also move one over to the right? Let's see. Otherwise, if the head and tail aren't touching and aren't in the same row or column, the tail always move one step diagonally to keep up.
On the instruction.
Is that in the...
Yeah.
Okay, so I'm an idiot.
No, you're not.
Let me see. If the head and tail aren't touching and aren't on the same row or column, the tail always moves one step diagonally to keep up. Okay. Yeah, but I didn't need to implement that because I saw a different relationship and I used that and I wrote something which is pretty smart, but when you don't see this, it really messes you up later. So as I said, I've looked at all the moves and I saw a relationship between the moves. So I didn't have to do this because I saw a different relationship and took a shortcut there. So yeah, and now it bit me in the ass pretty hard. Okay, so it always does a diagonal move. If it's not adjacent anymore and not in the same row and column. Okay. So yeah, then it's just calculating the diff and looking at which axis is off most. No. Boom, 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 boom. Yeah, I need to normalize it to 1, -1, etc. So that... okay. How do I code that? Let me see. Because I've been messing around so much that this is all just a terrible mess now. Okay, so if it's not adjacent, let's just... Should probably modify this one as well. Should probably not use this one anymore now and just do it there. So I can still use this and then not care, but for this I need to do okay, diff x is this. Okay, let's see. Int diff x, diff y. Diff y is, and it's also just y. Okay. I can actually do that differently. So we do if pref not dot x isn't current not dot x and pref not dot y isn't equal to current not dot y. Then we also need to shift an additional one based on which one of the moves isn't correct. So let's see. If move.x is 0, move.y plus equals move.y Yeah, so we increment it by itself. So if it's negative, it adds another negative. If it's positive, it adds another positive. That is not, wait, let me see. That's not correct. Because it needs to move towards the other one. Let me see. Move.x is that we need to compare it. So if it's smaller than, let's see, if the previous one is larger, need to add 1 or else minus 1. Else, boom, 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 boom. Okay, let's see. Oh, and then it's also get inverted there, so that's annoying. Let's see. 4 minus 1 to 0. Okay, so this one needs to move, and it says that the move that it did was already diagonally. I probably need to know that after the move, right? Yeah, if after the move it's not, it needs to move 1 extra 1. And so it needs to know current not compared to new pos. Let's see if I did this correctly, right? Yeah, I know. I changed that there. Let's see. Let me read it again because I is ever 2, alright, also move 1 step in that direction so it remains close enough, otherwise the head still always moves 1 step there to keep up. Okay. So it needs to know that beforehand, and then it needs to add 1 to the move. But if this move is already diagonally, I should not let it move like that. Something tells me I still need to do my old logic, but add this step. Because it says it also needs to move diagonally, so you need to do a move plus the diagonal move. But I already take into account the absolute move.
Always, not also.
What, sexy?
Always, not also.
Yeah. Let me see when this triggers. Man, I'm struggling with this. Whew. And it never triggered that, by the way. And it's also still in disconnected states, right? While moving or not? Oh no, I still print it. while doing instructions. Let's see what my map looks like. What messes up here? Okay, how long have I been streaming for? Too long already. Okay, I'm just gonna cut it out here because I need to do other work, and I'll revisit it when I had some time to relax and think, and I'll probably rewrite this entire part and follow it. So yeah, I'm sorry guys. I'll finish this later and I'll get back to it tomorrow. So thank you for seeing me struggle for like nearly 2 hours. Yeah, this wasn't the one for me today.